Since I'm away, you're going to have to watch a video on the next part of the atomic theory. As we do that, let's just review a little bit. I guess the important part to keep in mind is that you've got isotopes. So isotopes have the same number of protons, but different number of neutrons. So for example, oxygen, we think of oxygen as 16, but you can have oxygen 15. So then you'd have 8 protons for the oxygen and 7 neutrons. I see that's a mistake right there. Oh well. And then the other thing is the forces between the neutrons and the protons are much greater than the forces between the electrons and the protons. If that wasn't true, the atom would be blowing itself apart. Okay, so that's where we were 2 weeks ago. Let's move on to this week. If you know the charge of an atom, and you know the number of protons in that atom, you can figure out the number of electrons as well. You've got to use that equation that we had for charge. Charge is going to equal protons minus electrons. And the other way you can do it is you can think if it's got a negative charge, that means it's got electrons added. If it's got a positive charge, that means it's got electrons given up. We can do them either way, so let's look at the first ones that we want to practice. First ones we want to practice are beryllium and sulfur. Beryllium's up here, it's number 4. Sulfur's over here, it is number 16. So the first thing we want to do is figure out how many electrons are in beryllium and how many electrons would be in sulfur if they took the charges that we think they should take. Okay, so what we're going to do right now is not neutral atoms, but the charges on atoms that we think they ought to take. And to do that, move the camera quick. To do that, just grab a periodic table. Remember, everything on the first column's got a specific charge. It's +1. Everything on the second column has a specific charge. Everything on the last column has a specific charge, 0. And then -1, -2. You should know the charges on the columns by now. Let's look at beryllium first. Beryllium, I know, has an atomic number of 4 and a charge of +2. So I've got beryllium. That's 4, and if it's got a +2 charge, that means that it has lost 2 electrons, so I can subtract 2, which it means it has 2 electrons. I can use this formula up on top. Charge equals protons minus electrons. I can do that as well. And if I do that, I get charge equals protons minus electrons. Now I want to solve for E. To solve for E, then I can subtract 4 on each side. And I get E to equal 2. Doesn't matter which way you do it, you should get beryllium to have 2 electrons. Sulfur should be just as easy. It takes a -2 charge, so sulfur is number 16. If it takes a -2 charge, that means that it's added 2 electrons. So now it should have 18 electrons. I'm going to write an electron with a E negative. I'm assuming by now some of you are discussing how to review this quick, so just take 5-10 seconds. Look at your partner and make sure that you understand how we did beryllium and how we did sulfur, and ask your partner, because it's going to be very difficult for you to ask me right now. And I'll solve this while you do that. Okay, so hopefully you've figured out how to do all of these things. Now, the next step, you should have a worksheet for today. Problem number 1. You're going to take all of the ones on the periodic tables and fill in their number of electrons. That is, if they take the charge that we think they're going to take. We just did, what did we just do? We just did beryllium, that was 2. And we did sulfur, which I think is over here, and that was 18. I can help you out. Hydrogen +1. Okay, well that's hydrogen is normally 1. If it's positive one charge, that means you have removed the electron. That means hydrogen has 0 electrons. It's the only one like that. Helium will be what it says it is. Neon will be what it says it is. Argon will be what it says it is. All of those have no charge, so we can just leave them with their number of protons. Now fill in the rest, and remember to skip carbon and silicon. Let's see, fluorine, oxygen, nitrogen, carbon, and silicon should be right there. Skip that column right there, and I'm sure you'll see why. Okay, take about 4 or 5 minutes and fill in number 1. If you fill in number 1, then head on to number 2, and we'll start back with number 3.